Okay, so to graph relations and identify functions. Now the leaf that you just did, that would be an example of a relation. It was a series of points. However, it is not an example of a function. And maybe that sounds a little bit weird right now because you're like, oh, well then what's a function? But I think a lot of you guys, it'll trigger once we start talking and identifying what's a function and what's not a function. As soon as we get there, you guys will, it'll kind of come back to you from Algebra 1. So a relation is a set of input to output values. So these are coordinate points. In that plotting activity you just did, you plotted a whole series of points. Okay. Now the domain is going to be the input of the relation. So for example, when you guys were plotting all those points, it was the x coordinate. Okay. Okay, so the range then is going to be the output values of the relation, which are your y coordinates. And then a function, okay, so we can have these relations, but then you have to ask, is it a function? And in order for it to be a function, it has to be each element of the domain is paired with exactly one output, okay? Which is an element of the range. And we can test to see if something is a function using the vertical line test. So for some reason, the vertical line test typically usually triggers your memory about a function. Does that sound familiar? When you do the vertical line test and if it hits the relation more than once, then you say, nope, not a function. But if you can put that vertical line anywhere on your graph and it only ever hits the line once or a point once, then it passes the vertical line test and it's a function, okay? That's what the vertical line test is. So for example, if I had a graph that looked like this, and I had a curve like this, anywhere you were to draw a vertical line, it would only ever hit this curve once, no matter where you draw that vertical line. So yes, this is a function. Okay, but if I had something that looked like this, something like that, and I were to draw a vertical line through it on this one, look what happens. I draw a vertical line almost anywhere, and it's going to hit that curve twice. And so because of that, this fails the vertical line test. This is not a function. Do you see the difference? Give me like a 1 through 5. That looks really familiar. I remember that. Down to a 1. I've never seen any of this in my life. Where are we at on that scale 1 to 5? Okay, good. Okay, so the next one says graphing a relation. So it gives us 5 points here, and we have to graph it. So let's see. We are going to, gotta have some axes on our graph here. So I'm gonna put them right smack dab in the middle. And I'm just gonna do a scale of 1. I don't like to label every one though, because then my numbers get super crowded. So what I'm instead gonna do is I'm gonna count this as 1 and label this as 2. 3, 4, 5, 6, 6, 7, 8. And so I don't label all of them, but I did count every one. -1, -2, -3, -4, -5, -6, -7, -8. And I'm going to do the same thing for my y-axis. All right, so before I even get to labeling, down at the bottom it says label the 4 quadrants in the graph above. So I just want to show you what these are so that you have seen them before. This is quadrant 1. We name them with Roman numeral numbers. Okay? So 1 is where all of your coordinates are positive. And then from there, we actually are going to number these counterclockwise. So not the way you would think it would go. This would then be 2. So you're just counting up. 3. And then 4 is right here. Are we okay with those Roman numerals? Okay. So that's how we can label the 4 quadrants. So if we're talking about a specific quadrant, we want to name it, that's how you name it. 1, 2, 3, or 4. All right, so now we're actually going to go and plot these points, those 5 points that it told us. And that's why we did that plotting activity today, because it's important we know how to graph these points. So this says go left 2, up 4. So left 2, up 4. You have a point there. Right 3, down 2. Right 3, down 2. It's right here. Left 1, down 4. It's going to be here. Right 4, up 5. Will be here. Left 6, up 4. All right. So then we have to say, all right, well, now that we have those points on the graph, is this a function? It asks over here in this little box. Is this a function? Okay, well, it doesn't want us to connect the line because this relation is just a series of points. So I'm not going to connect them. But what I can do is I can do a vertical line test through each of these points. Does it pass here? Yep, it passes. So move on to the next one. How about here? Does it pass here? Yep. How about here? Yep. Does it pass here? Yep. Does it pass here? And I think that's all 5 points. So it passes the vertical line test everywhere we need to test it. Okay? And so because of that, is this a function? We can answer yes. You could state that it passes the vertical line test, but that's not the explanation I'm looking for. The vertical line test is your test to say, is it a function or not? But that doesn't explain why it is a function. To explain why it is a function, you have to use the definition of a function. So you have to say, yes, for each input, there is exactly one output. That's super hard to read, so I'm going to write it up below too. Yes, for each input, there is exactly one output. So if an input is -6, the output has to be 4. If the input's -2, that output has to be 4. If your input is -1, your output is -4. Yes?
Couldn't you look at all the x coordinates and if there's any of the same numbers?
Correct, but when you would go to explain it, you would still have to say no, because the x value such and such goes to both this and that. And then that would be your explanation as to why it doesn't work. But when you go to explain it, yes, you can identify it by looking at your x values here. When you go to explain it, you just have to say for every input, there's exactly one output. Okay? Because if you had a repeated x, then yes, you wouldn't have exactly one output. You'd have 2 outputs, which is what makes it not a function. So when you go to explain, you have to use the definition to explain it. But yes, you can identify it like that way too. All right, can I go ahead and flip the page? All right, so looking for the domain and range, and is this a function? So on this one, when we're not graphing, we're going to use that idea. We're going to have to look and see if there are any x values that repeat that would go to the same y, or to different y values. So your domain are which ones? What are your domain? The x values. So x is an element of, you're going to use a curved E. Okay? We'll write it up here. This is an element of. That's what it means. X is an element of, so the domain is x is a part of, and you have to use the squiggly brackets here in order to define the set. Okay? When you're defining a set, you're going to use a squiggle bracket, and you're going to close it with a squiggle bracket at the end. Just like it gave you the squiggle brackets to identify the set at the beginning. Okay? So x is an element of, we're just going to list our x values. What you'll want to do, though, is you want to list them from least to greatest. Because if you just list -2, 3, -1, 4, -6, what happens is sometimes you accidentally repeat. And you don't want to repeat values. It's not necessary. So my lowest number is -6, so I'm going to start there. And then -2, -1, 3, and then 4. And you're going to close it with that squiggle bracket. Then we're going to do the same thing for our range. We're going to say y is an element of, and we're going to list the y values from least to greatest. So -4, -2. Now see how 4 is repeated? I don't want to write it twice. I only write it once. And then 5. Does that make sense? Why we write it from least to greatest? It's like if I was trying to come up with a list of names of everybody in first hour. And if I had 3 papers from one person, I'm not going to list that person 3 times because they're not in this class. There's not 3 of them in this class. There's only 1 of them in the class, even if I had 3 papers with their names on it. Does that make sense? Okay, so is this a function? Is this a function? Does each x value go to exactly one y value? Are there any repeating x values so that one x value goes to multiple y values? Are there any x repeating? Nope. So yes, this is a function. Now I'm not going to do the explanation again because it's the exact same as before. Every input goes to exactly one output. You're just going to explain with the definition. Okay. On this one, we can still write the domain and the range. We're going to use the squiggle brackets to do so. For the x, you're going to list all your x values, or for the domain, you're going to list all your x values from least to greatest. So we'll start with -3, then -2, 3, and then 6. Your y values are going to be -4, -2, 4, 5, 8. Now, is this a function? Is this one going to be a function? Why not? What makes this one not a function? What does? What are we thinking? Why is this one not a function? The answer's no here. Three and -3 are 2 different numbers, so that part doesn't matter. But look at what does repeat. The -2. So when we say no, our explanation here says the input, -2, goes to 8 and -4. So that is going to contradict what the definition says. The definition says each input goes to exactly one output. Here, an input goes to 2 outputs. That's not exactly one. So that contradicts the definition, which means it's no. Okay. All right, so just looking at the graph, we don't have to do a domain and range if it's a curve like this. But looking at this first one, is this a function? No. No, and you can see that if we were to draw a vertical line through almost anywhere on this, it's going to go through 2 points. So we can see the answer here is no. And you would just define it as the input goes to more than one output. The input goes to 2 outputs, etc., etc. All right, so then how about this one? Is this a function? Can we do vertical line through these and only hit it once? Yeah, so this one's a yes. Each input goes to exactly one output. How about this one here with the points on it? Yeah, but look, it passes the vertical line test. Passes the vertical line test, passes, passes, pass, 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 pass. So is this a function? Yes. Okay. And for your domain, let's figure out all your x values. So what I like to do is I kind of put a straight edge here and say, okay, my first one's -4. The next point's at -3. The next one's -2, 0, 1, 2, 3. So sometimes having that straight edge kind of helps guide you to what x values do you have there with those points. For the y values, we're going to do the same thing. Start with your lowest y. The lowest y is going to be -2, then 0, then 2, 3, 4. Now you can see there are y values that repeat when we do that. Does this matter? Does that have any change in effect? No, it doesn't matter. That's a horizontal line test. We're not looking for horizontal lines there. Okay. The last one is a mapping diagram. Okay. And if it gives you a series of points, the same way we listed the domain and the range is exactly what you're going to do in the mapping diagram. So list them from least to greatest. So for your x values here, we have -2, -1, 3, and 4. And for our y values, we have -4, -2, 0, 4, 5. And then I believe you guys did mapping diagrams back in Algebra 1. But once we do this, what we're going to do is we are just going to draw an arrow to where does -2 go. So if you look at each point separately, then we can draw our arrows. -2 goes to 4. So you're going to draw an arrow from -2 down to 4 with an arrow. -2 goes to 4. Go to your next point. 3 gets mapped onto -2. So we're going to go from 3 to -2. So put your arrow towards the -2. -1 goes to -4. 4 is going to go to 5. And -1 is going to go to 0. Now remember, for it to be a function, each element of the domain has to go to exactly one range. So is this a function? Why not? -1, no. And then we're going to write this in here. Hopefully we can read this one a little bit better. So our answer is no. And the way we would explain it -1 in the domain, or the input, -1, goes to both -4 and 0. And that's what contradicts that definition. So no, the input -1 goes to both -4 and 0. And that's why that's not a function. We only have one more type of problem today, and it's looking at function notation. Function notation, it's the same thing as if someone were to give you an equation that looked like this. Y equals 3x plus 4. Okay? But the problem is if I wrote y equals 3x plus 4 and y equals -2x plus 5 and asked you to find when x is 2, I wouldn't know which equation you would want me to plug it into. And so function notation allows us to kind of name the different functions. Okay, name these equations. So this one I would call f, and this one I would call g. And that's what the lettering up front means, f of x and f of x and g of x. That's how we say those, f of x, g of x. So this first one, f of 2, says to find what that y value is going to be when x is 2 in the function f. So what we're going to do is we're going to replace all of the x's in there. So we're going to have f of 2 equals 3. Instead of x, I'm going to put parentheses. And instead of the x, I'm actually going to plug in what for x? I replace this x in the parentheses at the beginning with 2, so that means replace all the x's with 2. And then it literally just says y equals 3 times 2 plus 4, so we can figure out what the y value is. So I have 6 plus 4, because I'm just going to do PEMDAS to simplify that right side. It's just an expression. Well, 6 plus 4 is 10, so that means f of 2 is equal to 10. Now what that tells me, this is just giving you more information. If I said y is 10, that's great. I know y is 10, but I don't know what I plugged in order to get y to be 10. So if I write f of 2, then I know that I plugged in x is 2, y was 10 in the f function. Okay, so this function notation just gives you way more information than if I just had y equals there. And that's what the purpose of it is. We're going to try it again, and this time we're going to plug in -1. So f of -1 equals, f of x equals 3 times that x value plus 4. But I replaced the x value with -1. So I'm going to replace this x value with -1. Remember, don't worry about that left side. That is what it is. We're just going to use PEMDAS to simplify the right side. So we're going to do the multiplication first, so -3 plus 4. Once you add those together, you get 1. So f of -1 equals 1. Go ahead and try g of 3. So use the g function this time. I want you to try that one. So walking around, this looked really good. Most people were able to come up with -1. It is important, though, that you are showing that work, okay? But other than that, it looked really good. So that's the notes for you today. You can use the rest of the time today to finish up. You have classwork to do, and then an assignment after that, okay?